Okay, welcome everybody. I'm really glad that you came here today so numerous. And my name is Simon. I'm the co-organizer of this meetup. Maybe I'd like also to present Lucas. He's the organizer. And first I want to thank Smarty. Thanks a lot for hosting us today. I'd like to give the word directly to Moreno, who will tell some more words about what Smarty is and what they do. Thank you.
All right. Just a few words about our company. Basically a web development company who does full stack development. We were founded 6 years ago. We're 2 founders, now we have 12 employees. We did a little over 50 projects over those 6 years with for about like 15 clients, from big companies to small ones. You'll see a few of them like later on. These are like all our co-workers. Most of them are sitting over there, like in the CEO beer lounge, whatever that is. Yeah, and the special thing about our company is that we are all developers, so there's no project manager or something like that, so we call ourselves like 12 nerds. What we do is basically we do client-based projects. There we do that, and like we do full stack stuff. This is basically the tasks we are into. It's like from consulting and conception to like development, and also testing, data analysis, all kind of stuff. And it's basically it's full stack. So we do operations, we do backend stuff, we do front end stuff, and yeah. We try to live as agile as possible. So all of our projects we do using Scrum. Basically, it's also you see our Scrum board over there. And these are our customers. You might know some of them, some not. There's like small ones and also big ones like Migros or Globus and stuff like that. This is just a few of them, those that are probably most memorizable, basically. And what we basically love, that's what I said before, is like because we call ourselves like 12 nerds, it's like coding. So our tech stack looks a little bit like this. We do a lot of stuff in React and React Native using TypeScript in the front end. Our backend mostly is based on Node.js, also using TypeScript. And we have a couple of Symfony PHP applications and .NET Core. We use Elasticsearch heavily for like search-based projects in the backend. We started using GraphQL in some of our projects just recently. I think you'll hear some a little bit about GraphQL in general afterwards, in the first talk, I think. And on the infrastructure side, we use Cloud Foundry, Docker, and Kubernetes. It's basically our stack. That's it. I said it's just going to be a few words because I want to keep it short. If you want to find out more about ourselves, go to our website. It's on smartif.ch. Yeah. Oh, and some stuff I want to mention. Toilets over there, and there will be pizza afterwards. So stay and talk to us. There's beer over there, like behind that thing. Yeah, exactly. Just help yourself. There you go.
Just a short more words from me. The most important thing I forgot, because today is the first meetup where we are live. So I don't know if you read it before. So we are live on YouTube, and yeah, we'll see. Probably some people will also ask questions. If that's possible, and if you want to join, you can also join with the QR code. But yeah, that basically doesn't make sense. You can ask questions yourself. So I already welcomed, especially warm welcome also to our three speakers, Dennis, Nicola, and Yukai. Is Yukai here? I don't know, because I don't know. I will have a short word after that. Some words to our community, which started in 2016, and I would say we continually grew with a heavy peak in the beginning, but I would say it's I would call it a natural growing, and if we look at the last year, it's very interesting to see that we had a steady growth, and we are now over 400 members, which means, or which represents also a bit that the TypeScript community is growing, and I'm really glad about that. This is the last meetup this year, but there will be another 4 meetups next year. So normally we plan 4 meetups, one in March, one in June or July, one in September, and the last one in December. So if you want to join, already plan it in. It's always in the middle of the month. And I'll publish the dates as soon as possible. What I'd like to say also, contribution is very welcomed. For us, it's a great help if you come to us if you have topics to talk about. You can also host a meetup as Smartif did today, and then you don't have to organize the speaker yourself, so we can support you there. But if you want to hold a presentation, just come to me or write in the meetup group. And if you have topics you are interested in, just let us know, then we can also look for speakers. And if you are interested, you can also help organizing the meetup group and become part of the organizers team. So today's schedule is still a bit of a surprise, because the first talk will be Nicola from Smartif. He'll talk about fun times with Advanced TypeScript. So they are heavily using TypeScript, and he'll talk a bit about the usage, how they use it, what they learned, and the power of it. I will not talk too much now. And the second talk will be from Dennis about GraphQL together with types, or how you can use TypeScript together with GraphQL and React. And the last talk will be from Yukai. he wrote me last week because he was in Europe and was at the TypeScript meetup in Paris, and he asked if he could hold his presentation again today here. So maybe he'll join. I guess he's not here yet, but yeah, I'm looking forward. Maybe I hope he joins or she, you know, and it'll be really cool. Yeah, then let's dive into the first talk, and I'd like to give the word to Nicola, and thank you already now.
Okay, thank you from my side. Let's have a bit of a show of hand. Who has already developed with TypeScript? So yeah, basically everyone, that's fine. What's your favorite TypeScript feature? Just shout out.
Type checking.
Type checking. That's a good one. What else? Some kind of TypeScript feature that you really like?
Auto-completion.
Auto-completion, sounds good. Who among you is aware of the Advanced Types page on the TypeScript documentation? Okay, about 20%. Who among you has gone through it systematically? Okay, so like basically the ones who know it have gone through it systematically. Yeah, basically this is what I've done, and there is a lot of content, and some of it is actually examples that I basically invented, and some of them are taken from practice, from our own experience with TypeScript. And we have a lot of time. I want to dedicate as much time as you need on every example. So, like, if you have questions, just ask them immediately. I don't want to structure it like I talk, and then you ask me questions. Like, if there is something that's not clear, just raise your hand. We can talk about it. And in the end, we will publish both the slides and the kind of a medium article with basically everything. So if we reach only halfway, maybe in the next meetup, we will do part 2. So end of introduction. Let's start with some building blocks. Most of them you will actually already know. So these are intersection types. And okay, so a first principle is you have to think of types as sets of possible values, right? So if you have an intersection between two types, basically you have a narrower set of types. And this might be a bit counterintuitive because basically what is that? The duck is the type that implements both this interface and this interface. And of course that's a smaller set, but what you get is the kind of the union of all properties. Then what you have is union types. This is the opposite, right? So it's the union of the two sets. What you get is a type that has only the intersection of the properties, or basically the ones that they have in common. So the eagle and the butterfly can both fly. Okay, another interesting thing is here is, okay, let's say that you don't want to cast a type, but there is some custom logic to decide whether some type some object actually belongs to a type. This is what you can do here. So you can define a function that kind of checks in some kind of custom way. Okay, this is a flyable object, and then you can say the return type is like animal is flyable, which is basically a boolean, but it indicates that if this returns true, then TypeScript can assume that this is actually a flyable. So it's a kind of a safer cast. Of course, it depends on how safe your implementation of this function is. Okay, there's another little feature. If you know that something is not null or undefined, you can just put this exclamation mark. It's a kind of a handy cast. Okay, let's go on. And maybe some of you don't know that you can actually use individual values as types. So again, if we go back to the idea that types are sets, this is the set of just this one value, right? Like you could say string, the type string is the set of all strings, and this is just the set of the string rock. Okay, and this is basically a set containing three values. Okay, never. I don't know if you've ever heard of it. It's basically the return type of a function that doesn't return. So like if you throw an error or if you loop, that's never. And we are going to use this in weird spots later, as you will see. This is a new feature from, new TypeScript 3. And many of you abuse any, as I do. But don't do that. It's not good. But okay, if you this is actually a better type that you can use in some cases. For example, when you have like an input, a user input that you don't know what it is, use unknown because it doesn't allow you to assign this value to any other value. So you have to do some custom type checking if it's completely unknown. And any you can assign everything to any, and you can assign any to everything. So it's basically the kind of delete TypeScript logic feature. Okay. So index types, here we are starting to get a bit more advanced. You can infer that, like you can get types by inspecting object types. So key of duck gives you basically the set of all possible key types, so colors and feathers. And then you can get an actual a property. For example, so duck of colors has the type string. So this is resulting as the type string. Or you can actually do it of all keys, and then you get string or number. So these are the all possible duck value types. Let's go on. Conditional types. Okay, this is starting to get really confusing here. So basically, you know this operator, right? It has a similar logic in the type language. So you can basically you decide depending on t, it resolves a type or another one. So for example, this is a boolean, so it resolves to string. This is again a boolean, resolves to string. This is not a boolean, so it resolves to number. And again, like if you read the advanced types, you will see basically the definition plus some meaningful examples. Here I kind of split the building blocks, and they might be confusing, like what is this for? We will look at the applications in the second part. Okay, this is a small example of what you could do with this. So the type name of a string is the string, and TypeScript does this based on a kind of a concatenation of this conditional type. It's just one example. We will see more, especially as we start combining them. Okay, infer. This is a specific keyword that you can use within a conditional type. You can use it on the right side of extends. And it basically generates a type variable that you can use on the other side. Actually, especially only on this side, actually. So what this basically means is, if t is an array of something, then resolve to that something. And we don't know what it is. It's kind of like a type variable, but it appears on the right-hand side. And so, for example, this is an array of we don't know what, so of never, actually, because it has no elements. So this resolves to never. No, just a second. No, the never comes from here. Yeah, that's my mistake. And here you have an array of string, and so this type resolves to string. Let's move on. Okay, this was kind of like all the building blocks, the primitive stuff. And from here on, we can start talking about applications. I forgot to ask you if you have questions. So, okay, at this point, maybe, like, is there anyone who has any question about this? Or want to ask about something? Otherwise, I can move on and start talking about specific examples. Let's do that. Okay, this is a concept dear to me. It's not exactly about advanced TypeScript. It's just a way that I personally like programming, and that is enabled by TypeScript. And basically, there is this concept in clean code of separation between data structures and objects. And within that, naming an object is kind of a class that that has functionality and methods and so on, and the data structure is just pure data. It's an object that represents pure data. And I would go one step further and say we don't need objects most of the time. We just need functions that perform operations on those data structures. And the cool thing is you don't need to define any classes, any constructors for data structures. You just need to define what kind of values are there. No getters, no setters. It's very kind of slim, and I like this kind of programming very much. So, if, for example, you have this, imagine this is kind of an ETL pipeline that imports something and transforms it. This is all you need, right? You just get an input, a typed input, and you give it out a typed output. And TypeScript will really, like, if you make a mistake somewhere around here, it will just tell you. So you don't need any constructors or anything. You just need a function that transforms one object to the next. Okay, let's go on. Okay, this is an example of how you can discriminate unions. So we talked about unions. This is what the union look like. And so how can you discriminate between one or the other? Interestingly, for example, what distinguishes these three is the kind, not only that, but the kind variable. And you can actually really switch on this variable, and TypeScript will actually recognize, okay, in case it's an eagle, TypeScript will know it's the only type that actually has that value, and so you can call this method on it. If I didn't add this default, what the return type here would be string or what would it be? Okay, I think undefined, because you don't return anything in case it's a bird. And so if you actually, here is where we finally can use never. So if in the default case you don't return, then you can assume that this string is always defined.
I think if you don't have a default case, then it will be just a compiler error. It's exhaustive because the switch is going to be exhaustive.
Okay.
That's the compiler knows that.
What
I'm
if,
like 99% sure about it.
Okay, that's fine. So the question is, what if I type this as string or undefined?
No, if you skip the default branch. So if it cannot find any, if it cannot find any of the default cases, then it will just say that it will not compile.
It will not compile. Okay. I see. Yeah,
But would it also do
my
that
bad.
if your case statements are actually exhaustive overall?
If it's exhaustive, then it's not a problem. So if you would say
So this would be a
case,
case.
case duck and case just bird, then it would be okay.
Okay.
I see. Okay. So it complains if it's not exhaustive. I see. Okay.
But
Yeah.
wouldn't it be even more interesting to set the animal in Western never to the type never?
The assert never.
The animal there in the assert never. If we set it to never,
You mean up here or?
no, in the method or in the function there, if we set it to never,
Animal never here.
yes, then it would actually do the exhaustiveness check in TypeScript.
Is that so? Okay, I don't know about that because here, would you say no? Okay, would you actually like cast it to never? Because the question is, how can you know around here that the animal has type never?
Well, TypeScript knows that now it's not an animal, now it must be a bird in the assert never. So it would fail, and it would tell you you cannot do that.
Okay.
But it would do it during compilation time
I see.
instead of during runtime.
Okay. Okay, then yeah, I guess that's a part that I didn't know.
If you want to, I can show it to you later.
Yeah, that's fine.
Okay.
Thank you, please. Okay, I will add that to the article that we put in the end. Didn't know about it. Is there any other question about this? Thank you. Okay, something else is, okay, this is like a kind of small funny application that I found, which is, or I found, that instead of defining types whenever possible, I tend to use constants and then derive the types from them, so you can just kind of extend the constant and then this will automatically also improve the type. So for example here, assume this is like a configuration constant about different moves. As we extend this, the type move, which is key of type of moves, which is now basically the set of rock, paper, and scissors string, we will be able to use that as a, for example, as an input type of a function, and so that's quite handy. I will use that pattern later as well. Okay, this is what I talked about before. So if something is unknown, we can use something unknown to then handle it and return a number. So that this is how you would kind of like encapsulate all the transformation of something unknown into something known. So that's just an example. Okay, these were some miscellaneous examples. Here we move on to like specific applications of map types, and some of them you will have seen and heard already. So let's start. Okay, imagine we have an object, and we want to have a version of that object where everything is read-only. And this is what this type does. So it takes the type, and for each parameter in this type, it actually makes a read-only parameter, and this is then the type of the return value. So, for example, imagine we have a duck. I didn't show you the definition of duck, but you can imagine. So it has a color string and the feathers number, but then if you pass it through this read-only, then these two functions have become read-only. And now the same pattern can be applied to various different scenarios. For example, we have partial. So imagine you have an object with many properties, and what you want is to actually have an object that only has a subset of those properties.
And
this is
the read-only is not recursive, right?
No,
So I can
no.
still-
You can define that too.
Okay.
So you can kind of go down this lane. I haven't looked at that into details. You could actually do that. I've seen, I think on the TypeScript Advanced Types page there is an example, but I don't have it here. Okay, partial is basically doing something similar. It just adds the question mark in front of the parameter key, meaning it makes each individual key optional. You can do the opposite, like minus question mark, which means basically you make all the keys required. You can make them nullable by appending a null. Okay, this is like next step, next level. You can say, okay, I want to define a type that is derived from another type, but only taking specific parameters. And this is what you can do. So, for example, yeah, from duck, I will only want to pick the color, and then this is what you get, right? You don't have the feathers parameter. And the way it does it is that this k is then used as a set to restrict the p over which TypeScript iterates to define the actual parameters. Okay, then this is an example that I used personally. So imagine you have this. This is a library that basically does some SQL queries, right? And so what you can do is give the ID and then a list of strings, which are the things that then are selected from SQL, and automatically it picks those from the type, and so the result is only the type containing the subset. So that's one application of kind of a combination of different approaches. Another example is record. So record is a kind of a simpler idea, which is basically, okay, you define a subset and it creates, here there needs to be a comma party. So basically, yes, this would be the first type, which basically defines the kind of parameters, and then you need to actually add the second type, which defines the types of the actual values. So yeah, I'm using the wrong name. So this would be the index, and this would be the values. Okay. Let's move on. Another category. We talked about union types before. We can filter them. For example, like here. Okay. So what this allows you to say is, okay, I have one type, and out of this I want to extract this subset. Of course, here I could also have C, and which is not in here, and I would still have the result A. Since I think, if I got it right, since this is already a convention that people use, TypeScript introduced this with another name. I don't know if someone can confirm or deny that. Anyways, similarly, we have diff, which is now natively available as exclude. And so you can basically say, I want this type, and remove this subset from it. We will see some applications later. Actually, I think this is already an application. So if you have a type that can be null or undefined, with this you can basically remove the null or undefined, right? It's one specific application where you basically remove one specific subset, which is particularly useful in this case. Omit is a relatively popular one. It's a combination of pick and exclude. It does what it says, right? It's basically, I want this object type, but remove this property from it. It's the opposite of pick, basically, yeah, it is implemented by adding this exclude here. And here is a practical example that many of you who have programmed React with TypeScript and needed a hook, like a high order components, have used. So imagine, let's start actually from here. You have a username component that takes a user and a message. And this is the definition, right? User and message, and it returns, okay, this message, right? But let's say now we want to define a new component which does the same thing but based on the current user. We don't want to pass this user object all the time. And so what we do is we build a hook, and that takes a component and returns a new component where the properties omit these user props. So as you can see here, the resulting component doesn't have the user prop in here because we omitted it from the original props. And then what it does, it passes down the upper props, and then it sets the user explicitly. So this is how you type higher order components correctly. We talked about conditional types before. Here are some applications of conditional types. Can someone tell me the time? Like, how have I been?
It's 10 past 10.
Like, how long have I been running?
20 minutes.
20 minutes. Okay, let's go on.
25.
Are you tired?
No.
Okay. Are you awake? Yes. Good, good. Okay, function properties. Here you can see, like, this is kind of the more advanced stuff where you start in like kind of inspecting functions, and here using these conditional types that we talked about before, you can actually really extract the properties of a function. So, sorry. I was wrong. Like, you cannot extract the properties of a function. Imagine you have an object type that has different fields, and one of those fields is a function, and so you want the object that has only those fields. So basically, from a duck that has like, this is a variable field, and this is a function field or a method. Like this, we basically function properties. We extract only the fly part. And with function property names, we can extract the string. So at this level, there are, I have to say, many examples that I haven't used in practice. So I just had to kind of invent some. Would be interesting if you had an application, a specific one with the following ones. I have a few that we use, but not everything. Okay, non-function properties is the opposite, right? Out of duck, I just get color or the string color. Return type is simple. So imagine, okay. So what is? Let's look at it a bit more closely. What this does is, okay, we give it a t. If the t is a function that has a specific return type, then resolve to that return type. Otherwise, any. So we could actually, inside here, we could pass anything, and only if it is a function that returns something, then it will return resolve to that something. So here we passed a function that takes a string and returns a number, and TypeScript recognizes, okay, this is the return string, return type, and resolves R to that. Okay, this is an example where we actually use this. You can see here, return type. There is this Redis library, which is a bit frustrating because it works only with callbacks. And we like to use promises, sync await, and so on. There are some libraries that actually wrap that, but if I got that correctly, the typing is not there. Maybe I'm mistaken, maybe I just wanted to do it on my own. What it does here is basically, okay, it creates a client. Okay, so this is the classic Redis object, with all the callbacks in the functions. And here I create a kind of a promisified version of basically the methods that I need, using the util promesify function. And now this promesified Redis already has the type that I need in the end. I wrap it because I need to bind to Redis, but this is basically, you can ignore that. And imagine that I give this back, and then here you can basically take, okay, let's take the return type of the type of this function, and here you can already, so basically I didn't have to kind of define a new type that kind of is the same as the client type, but without the callbacks. That would be cumbersome, and here it's basically automatically done for me by TypeScript. Okay, instance type, this is kind of the last, I think the last type is, okay, same principle, but for constructors, right? So let's say you have a class duck. Now think about duck not as a type, but as a constructor function, so as a kind of a variable, right? A function variable. And what this does is, okay, let me think. This make2 is a function that takes a constructor, where is it? Here. Takes a constructor and returns an array with two instantiations of what the constructor builds. And so here we have basically two ducks. And the interesting part is the actual type that you get here, right? Like the type is the instance type of this constructor twice. So this would be a case. This is one of those cases where I have no idea how you would use it in practice. I guess if you start building some factories, or I would say probably higher level factories, something like that, then you would start needing this. That's it. Thank you very much. Do you have any questions? Or yeah. So, no? Okay.
I guess we have a 5 minutes break to change laptops, and then we'll be back.
Okay.
So feel free if you want to grab something to drink. Back there.
Okay.
No, we just meet